Electrostatics.
Good morning, student. Today we have to see the Van de Graaff generator. This Van de Graaff generator produces the high potential, and this high potential, which is utilized for to produce the highly accelerating charge particle. Right? Then here, first of all, we want to see the Van de Graaff generator. This Van de Graaff generator, which is designed by the Van de Graaff. Van de Graaff is the name of the scientist, right? So this generator, which is invented in the year 1931, and the principle of this Van de Graaff generator is, here the generator is based on the phenomenon of corona discharge, right? So this is the first working principle of this one. Now second one, what happened here? This metallic dome which collects the number of electrical charges, and after that charges which is distributed over the surface of this dome uniformly. And what happened? These charges are continuously accumulated by this dome. Then what happened? Due to that, the potential of this dome or this device, which is increases continuously. Right? Now this is the principle of working of this Van de Graaff generator. Now we want to see the construction of this Van de Graaff generator. First of here, the generator, which is the consists of the pulley P1 and P2, right? Over this pulley, here we kept one of the endless belt, that is called as the conveyor belt, right? And again, close to the pulley P1, there one of the spray brush is present. Now this is the spray brush. This spray brush spray the charges. And now here, this endless belt which is rotated, so that's why the charges which moves upward, and second brush which collect all the charges and which is deposited, or which is that charges which is given to this metallic dome, right? And this metallic dome which is also connected to the one of the filament, right? So this is the filament which provides the ions to this discharge tube. Inside the discharge tube, there potential difference is produced. Initially here potential is very high, here potential is very low. So that's why the charge particle which is accelerating to this discharge tube. And now here one of the electrical motor which is fitted to the pulley P1, right? And now here this metallic dome which is also fitted on the concrete pillars, but which is not shown here. Again, this whole setup which is placed inside this steel vessel, and which is filled with the nitrogen and freon. Here mixture of nitrogen and freon which is filled here. Because of here number of electrical charges, so maybe that charge produce the sparkling. So to avoid that, so here nitrogen and freon gas which is filled inside this vessel. Again here to the brush end, here the 50 kilovolt AC supply is provided. Right? Now this is about the construction of a Van de Graaff generator. Now we want to see the working of this Van de Graaff generator. First of here, the electrical motor which is fitted to the pulley P1. First of all, we want to start that. When we start that, then at that time what happens? This pulley is rotated, and due to the rotation of this pulley, this endless belt which is also rotated along this direction. Right here, this arrow shows the motion of a endless band. Then here to the brush end, here the DC supply, very high DC supply which is provided. And due to the DC supply, what happened? This brush spread the positive charges. Here, this positive charges. And what happened? Due to the motion of the bed, the charges which is moves in upward directions. Right? And here brush say which connects all the electrical charges. And that charges is deposited to the metallic dome. That is the dome shape hollow conductor. Right? And the charges which is deposited in this way. After that, the charges which is distributed uniformly. Right? This process is a continuous. It means that on this dome, there the number of electrical charges are present, and that charges produce the high potential. Right? And that potential is around 10 raised to 7 volt. This much amount of potential is produced by the charges. Right? So here, this potential is given to this I-shaped ion source. Here, this is the ion source. This ion source gives the ion to this charge tube. That ions may be their deuteron, or it may be that is the proton, right? Which is given or which is placed inside the discharge tube. Right? Here, this high potential which is also given to this tube, which is connected to this tube. So that's why that ion particles gains the large amount of energy, and here the potential difference between first end and last end, so that potential difference is very high. So that's why that charged particle which is accelerated with the very high energy, and finally that charged particle which is moves in downward direction, that is accelerated in downward directions, and which is escape from this discharge tube. After that charged particle is a highly energetical charged particle which is colliding on the target material. Here target materials are used. Right? So in this process, what happened? On this dome, there are the number of electrical charges. Sometimes their sparking may be produced. For to avoid that sparking or electrical contact, here nitrogen and freon gas is filled, and again their pressure is very high. So due to these two gases, here the friction of charges which is avoided. Right? So in this way, now this Graaff generator which produce the high potential and a highly energetical charge particle. Here, this Graaff generator which is utilized, this generator produces the highly energetical charge particle, then that highly energetical charge particle is utilized to disintegrate the nuclei of different elements. So this will be the first application. Again, the same Graaff generator which is utilized to study the atomic structure. Here, if you want to study the atomic structure, then at that time we use their Graaff generator. Again, to produce the highly energetical isotopes also. The generator produces the highly energetical isotopes. And again, such a type of generator which is utilized for the cancer treatments also. Right? So this is about the Graaff generator. See once all these things. Right? Thank you.